Hi guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Jest, Tifr, IIT-Jam and other exams related to physical science. Okay, so in this lecture, we are going to solve CSIR NET Physics PYQs of December 2019. Okay, so before starting the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes, which are going to help you to crack the examinations related to physical science. So guys, I'm going to start with first question today. Okay, so before that, I'm just going to check whether I'm audible or not. Just give me 1 second. Free live. Yes, I'm audible. Okay, so I'll start now. Question number first. The question is, just let me take the question. Okay, question is a uh, positive, positively charged, a positively charged particle is placed at the origin is is placed is placed at the origin at the origin placed at the origin with zero initial velocity with zero initial velocity. Okay, in the presence of in the presence of in the presence of a constant of a constant presence of a electric constant electric and a constant constant magnetic field along the positive z along the positive z and x direction and x direction directions respectively at large time the overall motion the overall motion of the particle of the particle overall motion of the particle is adrift along adrift 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 means movement. Okay, adrift adrift along the options are option A, positive y direction, positive y direction. Option B is negative z direction, negative z direction. Option C is positive z direction, positive z direction, positive z direction, and option D is negative y direction, negative y direction. Okay, negative y direction. Okay. So question is, a positively charged particle, the particle is positively charged, is placed at the origin. Okay, it is placed in origin with zero initial velocity. So its velocity is zero initially. Okay, in the presence of constant electric and a constant magnetic field. Okay, which are along the positive z and positive x directions, okay, respectively. At large times, the overall motion of the particle the particle is drift along. Okay, so in which direction it will drift. Okay, so that options are positive y direction, towards negative z direction, towards positive z direction, or towards negative y direction. That we need to find out. Very simple question. I'm going to solve it. Okay, so initially charged particle, right, initially charged particle will experience electric force. Okay, okay, initially charged particle, initially charged particle charged particle initially charged particle will experience will experience will experience electric force. Okay, electric force, and will gain, and because of that that particle will gain velocity. Okay, and will gain velocity, then because it has got velocity, then it will deflect, then it will deflect, it will deflect it will deflect in the magnetic field, in the magnetic okay, so particle will be at origin. Okay, and then because of electric field it will get the moment, right, momentum and motion, right, get velocity, and then because of magnetic field it will deflect in the magnetic field. Okay, magnetic field, and we know that f is proportional to and then the force on the particle will be proportional to v cross b. V is the velocity, and b is the magnetic field. Okay, and obviously, and this will be perpendicular to v and b, right? So it means that will be in positive y direction, Okay, so it will go in y direction. I'll explain it by figure. This is Q1. So this is x direction, this is x direction, this is y direction. Okay, and this is z direction. Okay, so magnetic field is here, sorry, electric field is here towards z direction, positive z direction, and magnetic field is toward x direction, positive x direction, right? So the the path of the particle is going to be, charged particle is going to be like this. Okay, so this is like this one. So it will go along y direction, positive y direction. Okay, and this path is cycloidal path. Okay, cycloidal path. Okay, this is cycloidal path. Okay, this is cycloidal path. So initially particle is at origin. Okay, so and velocity of particle is 0. Because of electric field, it will get the motion or get velocity, and it will deflect towards magnetic field B, right? And the force will act perpendicular to velocity and B, and because of that, the particle will move towards positive z direction. Okay, positive z direction in cycloidal path. Okay, so this is the concept. It's concept based question. Okay, so the path of the charged particle is cycloidal in the positive y direction. Okay, because E and B are in positive z and x direction respectively. Okay guys, so this is the answer. So which option is matching? Let me check. Option A, positive z direction, positive y direction. Okay, positive y direction, positive y direction. Okay, next question guys. Question number 2. Question 2 is, this is also a very good question from probability. Okay, I will explain it in very simple method. A box contains 5 white ball, 5 white and 4 black balls. 4 black balls. Okay, 2 are picked. 2 are picked. 2 are picked. 2 are picked. 2 are picked together. 2 are picked together at random. Together at random. Okay, at random from the box. From the box, what is the probability? What is the probability? What is the probability that these two balls are different, are of these two balls are of different colors, are of different colors. Are of different colors. Options are 1 by 2. Option B is 5 by 18. Option C is 1 by 3. And option D is 5 by 9. Okay, so this is the question guys. Question is, a box contains 5 white balls. Okay, a box contains 5 white balls, 4 black balls, 2 are picked together. So we have picked 2 balls together at random. Okay, randomly we have picked together from the box. Okay, what is the probability that these two balls are of different colors. Okay, so I'll solve it. So this is the box. In this box, 5 white balls and 4 black balls. Okay, and 2 are picked up randomly. So we need to find out what is the probability of finding these two balls are of different colors. Okay, so this is going to be, by formula we are going to solve it. So probability that two balls are of different colors is going to be, P is going to be this one, 5C1, because 5 white balls, 4 black balls. Okay, 5C1 into 4C1. Okay, one white ball, one black ball, C1 upon 9C2. Okay, 9C2. Total balls are 9. Okay, 9C2, and we have picked 2 balls, right? So 9C2. So what we are going to do, 5C1, we have picked 1 ball from white. Okay, and 4C2 means we have picked 1 ball from black. Okay, because there are 4 balls and we have picked 1. There are 5 balls, we have picked 1, and total balls are 9, we have picked 2. Okay, so this is the formula, guys. Okay, so P equal to 5C1, 1 ball from 5 balls. Okay, 5 white balls and 1 ball from 4 white balls, and we'll divide it by total balls from, so we have taken total balls from 2 balls, because we have chosen 2 balls together, right? So that means total ball C2. Okay, so 9C2. Easy, now we'll solve it. It's very simple calculation. 5 factorial upon 4 factorial into 1 factorial into the 4C1 value is 4 factorial upon 3 factorial into 1 factorial upon 9 factorial. 9C2 means 9 factorial upon 2 factorial into 7 factorial, right? We'll solve it. So this is going to be 5 into, so we can write 5 into 4 factorial here, and we can write 4 factorial into, here we can write 4 into 3 factorial upon 3 factorial into 1 factorial upon 9 into 8 upon 2 into 7 factorial into 7 factorial. 7 factorial, 7 factorial get cancelled, 3 get cancelled, 4 will get cancelled, right? So this is going to be 5 and 9, right? So this is going to be probability of finding particle of different color, balls of different colors. So this is going to be, is going to be 5 into 4, going to be 5 into 4, this one, 4 get cancelled, 5 into 4, 2 will go up into 2 upon 9 into 8, 9 into 8, this 8 will get cancelled, so P is going to be 5 by 9. Which option is matching? Option D is matching. Option D, 5 by 9. Okay, 5 by 9. So this is the answer, guys. Very simple. There are 2 balls. Okay, so there is a formula for 2 balls. So we have to find the probability of getting 2 balls of different color, right? So this formula for this is P equal to 5C1 means 1 ball is chosen from 4 white ball. 4C1 means 1 ball is chosen from 4 black balls. 1 ball is chosen from 5 white balls, and 1 ball is chosen from 4 black balls upon total. So 2 balls chosen from total balls, that is 9C2. Okay, we solve it and got the answer. Very simple. Next question. Next question is, This is also a good question. Question number 3rd. Which of the following terms which of the following terms when added to Lagrangian L, which is function of x dot y, which is my apology, which is function of x y, comma x dot y dot, okay, function of x y comma x dot y dot of a system. Which of the following terms when added to the Lagrangian of a system with 2 degrees of freedom will not change which of the following term, okay, will not change the motion of the equation, change the equation of motion, okay, change the equation of motion, okay. Options are x dot minus y dot. Option B is x y dot minus yx double dot y double dot minus yx double dot. Option C is x y dot minus yx dot, and option D is x yx dot square minus yx dot square plus x y dot square. Okay. Okay, so question is which of the following terms when added to Lagrangian. So Lagrangian is given. When added to Lagrangian, Lagrangian of system with 2 degree of freedom will not change the equation of motion. Means adding that term, which if we add on the Lagrangian, that will not going to change the equation of motion. Okay. Okay, so I'm going to solve it. So Lagrangian is given. That is L, which is function of x dot y dot. Okay, this is the Lagrangian given. Okay, so now what this Lagrangian equation is going to be, we know d upon dt del L upon del x dot plus minus del L upon del x equal to 0, and for y the Lagrangian is d upon question number 1. Okay, and this is d upon dt del L upon del y dot minus del L upon del y equal to 0, equation number 2. Okay, So del d upon dt del L upon del x dot minus del L upon del x equal to 0. This is equation number 1. And d upon dt del L upon del y dot del L upon del y equal to 0. So these are the equation, okay, equation of motion for the Lagrangian. Now we need to find which term, okay, which term uh, in out of these four, which term will is not if we add in the Lagrangian, not going to change the equation of motion, okay. So we'll take the option B, okay. So this one. So what we are going to do now, a new Lagrangian, we'll add this one, okay. We can check one by one. I'm directly checking this one, okay. X y double dot minus y x double dot, okay, this term. So we have what we have done, we have added Lagrangian, okay, this one, okay. So new we have, this is the Lagrangian, we have added y, we have added x y double dot x y double dot plus y x double dot, this term, okay. This term we have added in the equation. So according to question, this is not so we need to check whether it is going to change the equation of motion or not. So new Lagrangian is going to be L dash, or that is going to be L plus x y double dot plus y x double dot, okay, right. And then the Lagrangian the equation of Lagrangian of motion is going to be the first one will be this one, del L upon del t del L upon del x dot, okay, plus, sorry, my apology, this is minus del L upon del x, and this is going to be plus y double dot, okay, equal to 0. And for y it is going to be, we have differentiated with respect to x. And again we'll find second Lagrangian with respect to y. So this is going to be del L, this we can say equation number 3, okay. So this is going to be del L upon del y dot, okay. Del L upon del t del L upon del d d upon dt. So we have to say here d upon dt, okay. So this is going to be d upon dt del L upon del y dot minus del L upon del y plus, we'll differentiate this, okay, this is equation A. So this is going to be x y with respect to y, this is going to be y double dot equal to 0. This is equation 4. So from equation 3 and 4, this value, so from in this equation 3, from equation 1 this value is 0, right. This term we can this term is going to be 0, right. So from equation 1, equation 3 is going to be from 1, equation 3 is going to be this one. This will become 0 because this value is 0 by from the equation 1, okay. So this is going to be 0 plus y double dot is going to be 0. That implies y dot equal to constant c1, that is any constant. Similarly, from 2 to 4, from 2, this equation, this value d upon dt del upon del y dot minus del L upon y is 0, right. So from 2, this value is going to be 0, right. So 0 plus this, what mistake here, this is x and this is x double dot right, because we have this one y x double dot, okay. So from here we can see this value is 0, right? 0 plus x double dot is going to be 0. That implies x dot value is C2, any constant. So from here we can see y dot and x dot are constant. Okay, for this equation you can see x dot is constant, right? This is constant, and this is also constant. Okay, so these values are constant, means they are constant, so they are not going to change the equation of motion, right? Because these are the constant values. Okay, so these are constant, so these are not going to change, right? So it means the equation are going to be remain same, right? So this means because these values are constant, this means so this means this term, okay, is not going to change the equation of motion. So the option B is the correct option. Okay, guys. Well, next question, guys. Next question number 4. Okay, so now these are part C questions which I'm solving. Okay, part C questions started. Okay, so question number 4 is a good question. the outermost shell, the outermost the outermost shell the outermost shell the outermost shell of an atom outermost shell of an atom of an element of an element is 3D cube. Okay, so the outermost shell of an atom of an element is 3D3. Okay, the spectral symbol the spectral the spectral the spectral symbol for the ground state is, so the outermost shell is given. Okay, outermost shell of an atom is given, and the spectral symbol for the ground state, and we need to find out the spectral symbol for the ground state. Okay, for the ground state is, options are option A 4f 3/2, option B is 4f 9/2, 4f 9/2, option C is 4d 7/2, option D is 4d 1/2. Okay, these are the options. So I'll solve it. So this is for D, right? So this is 3D. We'll make a that orbital, 3D orbitals. Okay, one, two, three, 4, 5. Okay, 5 orbitals. 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this is minus 1 ml value. Okay, ml value, ml minus 1, oh sorry, minus 2, minus 1, 0, 1 and 2. So 3 electron, D3, yeah, 3 electron means this is 1, 1, 1. Okay, according to Pauli exclusion law rule. So here you can see this 1, 2, 3, 4, 5, right? So we can see this is less than half filled. Okay, the electrons are less than half filled. Okay, so in this case we'll find out in this case there is a condition. Okay, if it is more than more than half filled, in that case highest J value lies lowest, right? If it is less than half value, it is if electrons are less than half filled, in that case lowest J value lies lowest. Okay, okay, so these are the value of minus 2, 1, 0, 1, 2. Okay, now I'll solve it. So first we will find S. Okay, S value, highest S. Okay, highest S, highest S value, and that is going to be sigma ms. And ms here you can see from here you can see value of P equal to 2, because for D it's 2, right? And value of S is going to be 3 electron, half, 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 right? P. And value of L is 2. For L equal to 2, that is D, right? So highest S is going to sigma ms, means 1 by 2. S values are S value S, if S equal to half, yeah, right? So ms equal to sum of ms, right? This is ms, half plus half plus half. Highest value of S, that is 3 by 2, right? Now highest value of L, highest value of L is going to be mod sigma ml, right? Mod sigma ml. Ml values are here, right? I've made table this one. So this is 1, minus 2 into 1, because there is 1 electron, minus 1 into 1, 0 into 1, 0, 0. There is no electron, right? So this is going to be minus 2 into 1 electron, so 1, plus minus 1 into 1, minus 1 into 1, plus 0 into 1. Okay, mod. Here these values are 0 because there is no electron. Okay, this is how we find ml value. So sigma ml. So this is going to be mod 2 minus 2 minus 1 plus 0, right? Be minus 3 mod, and value is 3. So value of S we have found. Value of S found, value of highest value of S, ms, and highest value of S and highest value of L we have find. So because it's less than half filled, so the lowest value of J will lies lowest, right? This is a rule. So I'm writing this as well. If more than half filled, more than half filled, highest implies highest J, highest value of J lies lowest. Okay, these are one rule. Okay, if less than half filled, less than, let's say, half filled implies lowest value of J lies lowest. Okay. Well, so here because L value and J value are less. Okay. More than half filled means suppose there is one electron, there is also one electron, there is also one electron, right? Means these are more than half filled. Less than and less filled means that there is less than half filled means if there are electrons which are even not half filled, right? So this is less than half filled case. Okay. So here we'll find lowest J. We'll find lowest J, right? Because lowest J value lies lowest, right? So we'll write, so value of J is going to be sigma L minus S. Okay, if it would be highest J, then it will be L plus S, right? So this is going to be 3 minus 3 by 2, right? So this is going to be 3 by 2. So value of J is 3 by 2. Okay, so a spectral term is going to be, we know spectral term is 2s plus 1 1 2s plus 1 L J, right? So 2s plus 1 means 2 into S value is this one. S value is this highest S, that's 3 by 2, right? So 3 by 2 plus 1 L value is L. What is L here? L is given, right? So here we got value of L. L is 3, right? 3 means F, right? 2 means D. L is 3, so this is going to be F. Value of J is 3 by 2. 3 by 2. So this is going to be 2 will get cancelled. So 4F 3 by 2. This is the spectral term. Okay. Which option is matching? Let's see. Option A. 4F 3 by 2. 4F 3 by 2. Option A. Okay. This is the correct answer. Well guys, I hope you understood it. Very good question. Next question, guys. Question number 5. Question number 5. Question number 5 is, this is also a good question. Also it is from atomic and molecular physics. Okay. In a spectrum in a spectrum resulting from Raman scattering let IR denote the intensity of Rayleigh scattering and IS and IES denote the most intense most intense Stokes line and the most intense anti-Stokes line respectively. The correct order of these intensities is correct order of these intensities is options are IS greater equal to IR greater equal to IAS. Option B is IR greater equal to IS greater equal to IAS. Option C is IAS greater equal to IR greater equal to IS. Option D is IR greater equal to IAS greater equal to IS. Okay. So in a spectrum resulting from Raman scattering, let IR denote the intensity of relay scattering, and IS denotes the most intense Stokes and most intense anti-Stokes line. Okay, intense. Okay, IS and IAS is intensities of Stokes and anti-Stokes line. The correct order of the intensities is correct order of intensities. So this is most intense. Okay, correct order of intensity. So this is very good question. Okay, very simple. You should know it. I am writing for you. Okay, the intensity of relay line, very important point. Okay, intensity of relay line intensity of relay line intensity of relay line is always higher than intensity of Stokes line, higher than intensity of Stokes line, intensity of Stokes and anti-Stokes line. Okay, whereas the intensity of Stokes line is higher than anti-Stokes line. Okay, so you need to note it and memorize it, guys. Okay, so intensity of relay line is always higher than intensity of Stokes and anti-Stokes line. Okay, whereas the intensity of Stokes line is higher than anti-Stokes line. So if you talk about intensity like this, okay, this is the intensity of Rayleigh line, and this is the intensity of Stokes line, okay, and this is the intensity of anti-Stokes line, okay. So from here we can say that IR, the intensity of Stokes line, is higher than intensity of intensity of Rayleigh line is higher than intensity of Stokes line, and intensity of Stokes line is higher than intensity of anti-Stokes line. So this is anti-Stokes line, this is Stokes line, and this is Rayleigh line, right? So which option is matching? IR, IS, and this IS, B option, okay. Option B, IR greater equal to IS greater equal to IAS, okay. So you need to note down this point, okay. Intensity of Rayleigh line is always higher than intensity of Stokes and anti-Stokes line, whereas intensity of Stokes line is higher than anti-Stokes line, okay. Well, next question guys, question number 6. Question number 6 is, it's a good question, random walk related question. So question number 6 is a particle hops randomly hops randomly a particle hops randomly from a site to from a site to its nearest neighbor, site to its nearest neighbor, its nearest neighbor in each step on a square lattice on a square lattice on a square lattice of unit lattice constant unit lattice constant the probability of hopping to positive x direction positive x direction is 0.3 to the negative x direction to the negative x direction 0.3 sorry 0.2 to the positive y direction is positive y direction is 0.2, and to the negative y direction is 0.3. If a particle starts from the origin starts from the origin its mean position after n step is, okay. Options are: option number A, 1 by 10, n minus I plus j cap. Option B is 1 by 10, n I cap minus j cap. Option C is minus I cap minus j cap, and option C is n 0.3 I cap minus 0.2 j cap, and option D is n into 0.2 I cap minus 0.3 j cap. Okay, these are the options, guys. Very simple. Okay, a particle hops randomly from a site to its nearest neighbor in each step. Okay, on the square lattice of unit length. Length is unit. Okay, unit lattice constant. Okay, the probability of hopping to positive x direction is 0.3, to negative x direction is 0.2, to positive y direction is 0.2, to negative y direction is 0.3. If the particle starts from origin, its mean position after n step you need to find out. Okay, very good question. So I'm going to solve it. This is the condition, guys. Okay, I'll show you. So suppose this one. Okay, suppose particle is here, right? So it goes in x. This is x direction, minus x direction, y direction, minus y direction. Okay, so each step, like from here it will go this here, right? Or then it can go nearest either here, or here, right? And this unit, this length is unity 1. Okay, that's what is given. Okay, so we need to find out the mean position after n step. Okay, the mean position after n step is going to be, there is a formula. Okay, mean position, that is Ri, mean position Ri equal to sigma I Pi and Ri. Okay, so Ri is the mean position, right? So this is going to be Ri mean position mean position after n step is going to be, for mean position for one step we'll find out first. So this is going to be pi, right? Pi means that p1 from PIRI, right? This is going to be the probability of going x direction is 0.3 x direction, right? I cap into 0.3 into I cap, okay? Because I cap is, why I cap? 1 I cap, right? I cap is the direction. I cap shows the direction, okay? 0.3 into 1 unity I cap, okay? This is the direction, because 1 is the the lattice constant of unity, okay? This one, lattice of unit lattice constant, okay? Square lattice of unit lattice constant, okay? This one. Then this is going to be minus, in y direction it is 0.3, probability is 0.3 and 1 j cap, minus direction, right? 1 I cap, my apologies, minus I cap direction. So because we have to take care of direction, I cap for one particle, and then plus probability of going plus y direction is, this is 0.2, 0.2, which is given into 1 y means into j cap, right? And minus 0.3 into 1 into j cap, minus j cap, right? Because minus is here, right? So if we solve it, so this is going to give 0.1 I cap minus 0.1 j cap, okay? 0.1 I cap minus what, for one step we are checking, guys, okay? Alright, so this is going to be 1 by 10 I cap minus j cap, right? Because 0.1 will multiply and divide by 10, so 1 by 10 I cap. So this is for one step, guys, okay? So in one step it can go either there is 4 directions, okay? So for n step, Ri is going to be, for n step, that is mean position after n step is going to be, this is the after one step position, okay? So mean position after n step is going to be n into 1 upon 10 I cap minus j cap, right? So this is n upon 10 I cap minus j cap. So which option is matching, guys? Option B is matching, n upon 10 I cap minus j cap, okay? Option B is the correct option. Okay, guys, so very simple. First we have find out for one step, right? And this is the direction, right? It can go in 4 directions, here, right? Okay, so I cap, j cap are denoting the directions, okay? So for n step we'll multiply by n, okay? So this is the answer. I hope, guys, you understood it. So guys, I'm stopping here, okay? And before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the examinations related to physical science. Okay, guys, thank you. Bye now.